Let's take one example on waveform synthesis. Find Laplace transform of periodic function. Here one periodic function is given. This waveform is known as sawtooth waveform. Sawtooth waveform. So we are supposed to find Laplace transform of this sawtooth waveform. This is a periodic signal, as we know. At every t, see this is 0, at 0 the signal begins, and at every t the same signal will repeat. This kind of signals are known as periodic signals or periodic waveforms. If we find the Laplace transform of periodic functions, we should consider only one cycle of the periodic function. Now I'll take only one cycle, that is from 0 to t, because at every t the same signal will repeat. So we'll find only Laplace transform of one signal. Later we'll find the Laplace transform of entire signal. Now I'll draw the one cycle of the periodic signal, that is this is t, this is 0, this is t, and this is t by 2. Now I will call the first cycle or one cycle of f of t as f1 of t. That is, f1 of t is one cycle of f of t. Now we'll try to find the Laplace transform of f1 of t. Now here we can observe that the signal is like this, and it goes like this, and at this point it will go back to t. The magnitude at this point is 1, and the magnitude at this point is -1. So here we can observe that first we should get this point, this vertical line. So this is nothing but a step signal. So it consists of the step signal, so which is equal to, first it is made of the step signal. So this I will call it as something, say v1 of t. Therefore I can write the magnitude of step signal is 1. Therefore I can write v1 of t is equal to u of t. I will call it as first waveform. Now here we can observe that then there is a negative ramp signal which began at t equal to 0 and started from amplitude 1. So now we are supposed to find the slope of this waveform, that is nothing but, that is, we have the next waveform something like this. I will call it as v2 of t. Now we'll find the slope of this waveform v2 of t. We'll assume this point is x1 and y1 coordinates, and here at this point we'll assume that it is x2 and y2 coordinates, and we know that at this point it is t and the amplitude here is -1. So we'll try to find slope. We know that we'll calculate the coordinate values. Here x1 is equal to 0 and y1 is equal to 1, and here we have x2 y2 coordinates. X2 coordinate is t and y2 coordinate is -1. Therefore we can find the slope now. We know that slope is equal to y2 minus y1 divided by x2 minus x1, which is nothing but y2 is -1 minus y1 is 1 divided by x2 is t, x1 is 0, which is nothing but minus 2 by t. Now I can write v2 of t is equal to, slope of v2 of t is minus 2 by t into t, because it's a ramp signal t, u of t, as it begins at t equal to 0, that is u of t. We'll call it as second value or second waveform. Now observe this circuit. It should stop at a t equal to t. The ramp should stop at t equal to t. To make ramp to stop at t equal to t, we supposed to add one positive ramp at t equal to t in this way, like this, in this direction. So now I will add one positive ramp at t equal to t. Now suppose this is a point t here. I suppose to add one positive ramp. This is the positive ramp. I will call this signal as v3 of t. So now it is also having the same slope, that is, now it is positive, so the slope is plus 2 by t. Plus 2 by t, but it started at t equal to t. Therefore we can call it as shifted ramp signal. So I can represent here the slope is equal to 2 by t, that is plus 2 by t. Therefore now I can write v3 of t is equal to, slope is plus, that is 2 by t. The ramp signal is started at t equal to t, so I can write it as t minus t u of t minus t. So I will call it as third equation or third waveform value. So now if we add v1 of t, v2 of t and v3 of t, I can write here v1 of t plus v2 of t plus v3 of t will get the waveform like this. This is the sum of v1 of t plus v2 of t plus v3 of t. So this point will be t and this point will be t by 2. This is 0 and this is as usual t. So now here we can observe, we'll compare this waveform with this waveform. Here at t equal to t, this should go back to 0. As shown here, the waveform has gone back to 0, means here it is continuing. So now to make this step signal, to make it 0, I should add one positive step signal at t equal to t. If I add positive step signal at t equal to t, that positive plus 1 will be added with minus 1, it will become 0, so that the signal will come back to 0. So now I will add one positive step signal at t equal to t and I will call it as v4 of, my v4 of t is, this is v4 of t. So I should get v4 of t at t equal to t. Therefore I can write v4 of t is equal to, it's a step signal, it is nothing but u of t, but begun at t equal to t. So I can write it as u of t minus t. So this is my equation number 4. So these are the 4 waveforms we needed. When we add this waveform with this waveform, we'll get this waveform. That is, this waveform plus this waveform will get this waveform. That is what we needed. Therefore this is my first waveform, v1 of t. second waveform is v2 of t, third waveform is this one, and fourth waveform is this one. So now we are supposed to add these all waveforms to get the one cycle of periodic waveform f of t. Now we'll add, so therefore now my first cycle, that is f1 of t, is equal to v1 of t plus v2 of t plus v3 of t plus v4 of t. That is, v1 of t is nothing but u of t plus v2 of t is minus 2 by t minus 2 by t tu of t plus v3 of t is 2 by t t minus t u of t minus t plus v4 of t is step signal, that is u of t minus t. Now we'll apply Laplace transform to this entire equation. Apply Laplace transform. We can write f1 of t, Laplace transform of f1 of t is f1 of s is equal to Laplace transform of u of t is 1 by s minus 2 by t is constant, keep it as it is. Laplace transform of t u of t is nothing but 1 by s square, that is ramp signal, plus 2 by t is kept as it is. Now t minus t is nothing but Laplace transform of shifted signal. This is shifted ramp signal. So ramp signal, Laplace transform of ramp signal is 1 by s square. It is shifted by unit t, it should be multiplied with e raised to minus t into s, plus this is the unit step signal begun at t equal to t. So it is shifted step signal. I can write it as Laplace transform of step signal is 1 over s. It is shifted by unit t, so it is supposed to be written as e raised to minus t into s. So I can write it as 1 over s 1 plus e power minus ts minus 2 by ts square, that is 1 minus, sorry, this is supposed to be s square, so it is 1 minus e power minus ts. So here f1 of s is one cycle of periodic signal f of t. Therefore Laplace transform of periodic waveform f of t is given by f of s is equal to f1 of s multiplied with 1 upon 1 minus e power ts, where t is time period or period of given periodic function. So here the period of this periodic function is t, that is t minus 0 is t, therefore it is ts. So I can write it as f of s is equal to f1 of s is nothing but this entire term, that is 1 over s 1 minus e power minus ts minus 2 by ts square 1 minus e power minus ts, and this entire term is multiplied with 1 upon 1 minus e power minus ts. So this is the Laplace transform of the given periodic waveform, that is sawtooth waveform. Thank you for watching.